Howdy folks, Dayton Keene back. I'm a New River Community College instrumentation student, and today I will be covering Lap 4 Skill 5 with the basic hydraulic strainer and power module. We're going to be connecting a meter out flow control circuit, and we're going to be doing some testing with it, so follow along. First thing we're going to do is ensure our startup conditions have been met. We want the power unit powered off, the pressure relief valve knob fully counterclockwise, the shutoff valve closed, and we want nothing hooked up on the trainer yet because we've got some modifications to do. So let's take care of that and we'll get to it. Now we're going to set up our circuit. The circuit can be found in the lap manual itself, in the Module 4 Skill 5 guide that I have created in the PowerPoint, and we're going to put it on the screen for you here so you can pause the video if you need to look at that as well. Alright, let's start hooking up our circuit. So I'm going to get out my hoses, and today I am referencing the skill from within the lap manual to see my circuit that I need to hook up. So let's start there. Let's see. So our first run, our first hose, is going to go from the supply manifold to the in flow meter connection. Our next connection will be from the flow meter out connection to the DCV or directional control valve in port. So that should be T, I believe. And if this runs backwards, we'll show you how to take care of that as well. Alright, now from B, port B, we're going to connect to the cap end of our large bore cylinder here. From port A, we will be connecting to gauge B. Now you could do this with a T, or we can just use the built-in T that's here with the gauge. So our next connection is going to be from the other side of gauge B to our flow control valve right here. Following that, we will go from flow control valve to gauge A, and then our rod end of the large bore cylinder to the other side of the gauge A. We've got one connection left, which is from the P port of the DCV to the return manifold. Alright, so now that our circuit is hooked up, I'm going to take a couple pictures for y'all. I know these hoses can get hectic, that's why the schematics are nice, and then we'll power up and see if it works. Alright, now we got our circuit for Lap 4 Skill 5 in the basic hydraulics course, or fluid power course here at New River. We're going to power up the unit and we're going to test our circuit. So as with any circuit you've done before, power up, start the motor, using the switch. We're going to adjust our pressure using the pressure reducing valve, or pressure relief valve, excuse me. And for this circuit, we're going to go up to about 300 psi. Next, we're going to open the shutoff valve, and we're going to fully close our flow control valve and open it approximately 1/2 of a turn. So now we should be able to extend. It extends relatively slowly and retracts even slower. Alright, that's not correct. So, I've got my flow control valve reversed. So, I'm going to power the unit down by closing the shutoff, relieving the pressure, turning the switch off. Pretty simple. And to remedy this, we're simply going to reverse the connections on the flow control valve. So we power up again, set our pressure, open our shutoff valve. So we see pressure on gauge A as we extend, and then we see pressure again when we retract. And as you can see, the cylinder extends far more slowly than it retracts. That's the idea here with the meter out circuit. It's going through a needle valve for extension, and then when you retract, there's a check valve built in parallel with the needle valve that allows a higher fluid flow rate on the retract cycle. Alright, here's another view so you can see our cylinder extends extremely slowly, and that can be varied here. We can speed it up a little bit if we'd like using the flow control valve, right? But it still retracts at a pretty normal speed. So we've got extremely slow extend, normal retract. So we can also notice our changes in pressure on our gauges and our flow rate from the flow meter as we extend and retract our cylinder here. So now that you've played with this lab a few times, what we're going to try to do for the lab is achieve the slowest extend speeds possible. So what I would do is close your flow control valve all the way. So when you try to extend, nothing happens. It builds pressure. So next, we're going to just barely open up our flow control valve until we can just barely see some movement down here with the cylinder. And then you're going to time this to see how long it takes the cylinder to extend. According to the lab, it should take approximately 70 to 90 seconds in the slowest possible extend rate. So you don't need to see all of this, but we extended it out in time, the slowest time we can achieve. The next portion of the lab asks you to set certain pressures, or no, excuse me, certain flow rates while extending the cylinder, and to record some data based on that from your pressures and your extend time. So there's a table for that in your lab manual and in the guide and PowerPoint that accompany this video. So next step is shut it down and clean it up. Alright, now that we've finished testing our lab setup and doing our data recording, we're going to shut the unit down. So as always, we're going to shut the shutoff valve. We're going to back out our pressure relief module. We're going to turn off our switch. That completes power down of the power module. Next thing we're going to do is unhook all these hoses, cap them up, store them in our storage bag, place the bag back where our instructor has indicated that's best for it, and we will be done. So I'm going to take a minute, unhook all these hoses, put them away, and we'll be right back. Alright, so we've got everything powered down. Our hoses have been put away. Now the next step is some final cleanup. This is hydraulic oil. It does leak when you're connecting and disconnecting hoses and circuits and the like. That's why these trays are here, to help catch most of it, but some of it will get on the table. So the best thing to do is simply grab some paper towels, wipe up your area, try to keep it nice and clean. Take off your gloves, throw those away if you decided to wear gloves. And that's about it. If you really want to, you can check your fluid temperature using the temperature gauge as detailed in the previous video, and our fluid level. Both of these seem to be good. We're sitting at around 80 degrees on our fluid temperature, and our fluid level is sitting well in the green. So we're ready for our next lab, whether that be right now or next week, whatever time dictates. So I'm going to grab some paper towels, clean this up. Thanks for watching. I hope this video helped with basic, overall operation, but especially Lap 4 Skill 5 in the modules of a meter out flow control.